Okay, let's get started. So welcome to the Unstructured Data Meetup, South Bay. My name's Stefan, I'm the host. Also for Unstructured Data San Francisco, check that out too. So for those of you who haven't met me, name's Stefan and I'm a developer advocate with Zilliz. And if you're unfamiliar with what a developer advocate does, it's how I would describe it is we're sort of like the bridge between the developers and the users, in this case of Milvus, our open source vector database. So I really love generative AI, really love talking about all of this stuff. So hopefully get to meet some of you after the talks. Would love to connect and talk shop. Also, if you want to send me an email, LinkedIn, Twitter, by all means, very welcome. Firstly, I wanted to welcome the speakers for tonight. So aside from myself, we've got Cameron from is it TXT or .text? How do I say it?
We have no idea.
Startups.
The CEO gets mad at me. Exactly, there you go.
So yeah, we've got Cameron, infinite world generation with outlines. And so .text responsible for Python library called outlines, the structured output in large language models, which we'll be hearing about tonight. And then very fortunate to have Vaibhav from Boundary ML talking about a tool or a system they invented called BAML, which again, like a tooling for producing structured output from LLMs with a domain-specific language. And I mean, he'll explain it much better than I can. So before we get started, just a few housekeeping things. So please enter the raffle. So star us on GitHub, scan in the QR code, fill out the form, and you'll go in the running to win a prize. We'll run a raffle at the end. There's some really cool swag to pick up there. Okay, so I'd like to start off with a brief introduction to what is Milvus and what are vector databases and why should anyone care? Well, I think a good motivating example for vector databases is the application of semantic search, especially at web scale. So who here has heard of perplexity.ai or used it? Yeah, so I think I imagine your experience has been similar to mine. It really seems like it's going to be sort of the new way of doing search on the web. And for those of you who don't know, it's essentially like a chatbot at a very high level, a chatbot that can access data that it's archived from the web and other sources in a vector database. So you type in your question, it then goes off, pulls those matches from the vector database and presumably other sources, and then uses the large language model to synthesize a coherent output from that information. So I just asked it, what is a vector database? And I think this seems like it's better than the Wikipedia page. So I mentioned that I think like a killer application of generative AI is this semantic search at web scale. But why is it only sort of just being something that we're exploring? And why is semantic search difficult? Why has it taken it to 2023, 2024 to produce really widely used systems? I think the first reason is that semantic search requires good representations of words, sentences, paragraphs that capture the relationship between different types of those. So, you know, the relationship between the word dog and cat, for example. Whereas traditionally, you know, maybe like before 10 years ago, before deep learning really exploded, we would just be using these one hot or bag of word embeddings. And so these features, they don't say anything about the relationship between different words. So what's the relationship of Rome to Paris? Well, we don't know because it's just like a different entry in the one-shot encoding. And so yeah, so that's why semantic search has been challenging, why it's only just sort of exploding onto the scene. So I think one thing I want to mention is that semantic search offers a lot of benefits over traditional keyword-based lexical search. So for example, imagine we type in Apple into our search engine. Is that do we mean like fruit or the company? What if we type in rising dough? It might pick up, so I mean, it'll look for the keywords rising dough, literally, but will it know that proofing bread is an equivalent term that should also be searching for? And in the third example, the query is change car tire. And so will a keyword search be able to, like a lexical search, be able to understand what is the intent? Is it like when or how to change a tire? So why is semantic search important? Well, because 90% of data is unstructured. And we need semantic search to make to search this unstructured data to get the value from it. So 90% of newly generated data in 2025 will be unstructured data. And so that's documents, images, videos, audio, geolocation data, data from sensors, all sorts. So what's the solution then? Well, as of 10 years ago, say, we've had access to these really powerful deep learning models that can take our unstructured inputs, put them through an encoder, or put them through a deep neural network and turn them into these vector representations, which are just a sequence of numbers. And unlike the bag of words, these vector features actually capture the relationship between different words or different images. And so what we can do is we can do a similarity search in this high-dimensional vector space to find related entities to our search entity. And so here's an illustration of what I mean by we can relate the meaning between, we can sort of measure the similarity, or our feature space has like a notion of semantic similarity. So if, imagine we take these sentences, we put them through our deep neural network. If the sentences mean similar things, then we would expect the vector representations to be close in that space. And so that's the key point. So semantic search, very important. We produce all these embeddings via the magic of deep learning, but there's a new challenge now, which is search in this massive space of embeddings. And so some challenges are, how are we going to index this potentially hundreds of billions or even trillions of embeddings? How are we going to scale this? So how are we going to scale both the storage to that many vectors, but also the requests to retrieve? You can imagine in one extreme, something like AI getting sort of like that web scale traffic. And how are we going to handle multiple data types? So how are we going to sort of compare text to images to audio, etc.? Well, this is where a vector database comes in. And so I wanted to tell you about Zilliz. So that's the open source vector database that Zilliz produces, now controlled by the Linux Foundation for AI and Data. So it's an open source vector database that meets these challenges. So you don't have to worry about how am I going to index and search all of these embeddings. You can just put them into your vector database and request a similarity search be performed. So we've been lucky to have a really sort of powerful open source community with over 400 contributors, 30,000 stars on GitHub. So very good about that. Also, it's I think another sort of thing is like testament to the power and the quality of the software is the industry partners which use it for their applications, whether that's recommender systems, semantic search, RAG. They're using Novus. So I've got a QR code here. If you want to scan that, you can find out, that'll take you to our GitHub. You can find out more about what is it, how do I use it. We've got some really good tutorials getting started and some really good kind of like Jupyter notebooks to show some cool examples that you can go through. And then on the right-hand side, I've got our generative AI learning hub, which I think is another really good resource if you're new to generative AI. And we'll make all the slides available afterwards. Okay, but moving on to the topic for tonight, I want to talk about constrained sampling from large language models. So to begin with, let's just sort of go over like what's sort of the basic method of sampling from an LLM. We want to sample a sentence, so we sample our first word, and then we sample our second word, conditioned on our first, and we keep doing that, increasing the number of tokens that we condition on at each stage. So it's sort of like, yeah, a very sort of simple iterative process. So that's all well and good, but what if we don't want to just sample anything from our large language model distribution? What if we want the output to have a specific structure? What if we want it to be JSON or XML or mapped to like a particular data structure? Then we're going to have to make some change to this procedure, whether it's in the sampling or what we do afterwards. So is everyone here, or who's not familiar with what we call structured output from LLMs? So just very briefly, what we mean by structured output is output that you can sample from a large language model that has a well-defined format. So if you sample XML, then you want it to be well-formatted XML. If you want to sample, if your model is solving a classification problem, then you want the output to be one of the labels that is valid. So here are some, I think, sort of the main applications of structured outputs. So we've got classification, regression, I think like a coding assistant. Another example, you want to sort of take an instruction like write me a quick sort algorithm and do that in, I don't know, COBOL. You want the output to be well-formatted source code. You don't want to have to sort of like maybe post-process it afterwards, try and fix some errors. You want it to be robust and to produce that specific format. Likewise, for information extraction. Suppose you have, for example, like an image from someone's webcam, or could be anything like a painting, and you want to extract some information from that image. So maybe it could be like what objects are in it, some details about the environment. So presumably, or let's assume that you have like a really well-specified JSON schema that specifies exactly what you want to extract. So there's like a field for whether it's night or day, potential hyperlocation, that sort of thing. So when you do that, you want your output to have that specific schema that you specified. Likewise for agents, maybe using your large language model to make decisions to act in some environment. So maybe we have like a chess playing agent, and it takes the current setup of the chessboard and some context. Maybe that's embeddings of a chess textbook or some sort of knowledge that's helpful. And you want it to output a move or like the next move. You want that to be robust and reliable. Well, so one method to do that is, I think, just like instruct the model to do that. And so you probably go something like this. So extract the main details from the following resume and format your answer as JSON. Please make it well formatted. And that does work to some extent. That's what people do, but it's not like a reliable, robust way of producing structured output. And you're probably going to have to do some post-processing to your output. So another method that is reliable is this concept of guided sampling. And so the key idea here is that instead of just sampling in the standard way from our large language model, we actually take the logits from the final layer, and then we mask out all the tokens that we don't want to sample next. So you just imagine you've sampled the cat sat on the, and then the large language model by itself might sample Matt next. But maybe you don't want cliches in your output, so you say, okay, I'm gonna black out that logit corresponding to Matt, and then get it to sample table, whatever, wherever cats live. So in an algorithm, the modification between the basic sampling algorithm and this guided sampling is the two steps that I've circled in red. And so how it works is we construct a binary mask, so a matrix of, or a vector of zeros and ones that we can then pointwise multiply the logits from the large language model with. And that way it knocks out certain tokens that we don't want to sample next in order to give the desired structured output. So the challenge is really sort of how do we construct this mask? Do that in an efficient way. How do we construct it so that it matches a regular expression or a context-free grammar and so on? So one particular implementation is to use a finite state machine. And so the key idea here is we'll take a description of what we want the structure of our output to be. For example, a regular expression. We'll then build a finite state machine, which represents that regular expression. So in the slide here, we've got a regular expression that what it's specifying is numbers that just have digits and a decimal point. They don't seem to have the digit 0. I think that's a typo. So we want to be able to only generate those numbers from our large language model. So how it works is we simulate the finite state machine. So we say, given the starting state that we're in, we work out what are valid next tokens to traverse to. So there's not going to be like a one-to-one relationship between tokens and the characters in this regular expression. So we sort of have to do like a few steps, and we can, in advance, we can offline work out all of the next valid tokens from that state. And then once we've got that, we can then produce a mask function that all it needs to know is the state. And so given the state, it will then produce that mask, which when you apply it to the sampling process, you'll be guaranteed to have that specified structure. So just like a simple example. So let's suppose we want our structured input to be all numbers with only digits and a decimal point. And suppose that our tokens, so these are the tokens of our hypothetical large language model, A.42.2 and 1. So not very interesting, obviously like a toy example to illustrate things. We've only got 5 tokens in this large language model. So when we start off, well, the first thing you have to do is take that regular expression and build it into a finite state machine or automated. And so the one in the top middle, that's the corresponding finite state machine. And so when we start the procedure, we have a starting state 0, And we haven't sampled anything yet, so we just got the empty string. But, and so beneath that, we've illustrated the logits, the sort of the output of the final layer of the large language model, and the mask that's applied to it. So in this case, we need to mask A, because A is not a valid next token. You can see that we can sort of transition via a digit or a decimal point, but there's no transition that has an A. So we need to mask that token. So we mask that token, we then sample from the remaining tokens. And so in the bottom row, it sort of shows you like two hypotheticals. What would happen if you sampled .2 and what would happen if you sampled 1. So just imagine you sample 1. So that means that you go from state 0 to state 1, and you've sampled 1. So we'll update our string of what we've sampled so far. And then from this point on, any of the other 4 tokens that are not A are valid. So the mask is the same as the previous state. Whereas if we sample .2, in this case, so this is what I meant by there's not like a one-to-one correspondence between the tokens and the transitions in the state machine. So to sample .2, we make the transition to state 2 via a dot, and then we make the transition to state 3 via the digit 2. And then, so at this point, we're in state number 3. And so in state number 3, you can see that we obviously can't sample A. We can't sample the decimal point because the only valid transitions from state 3 are digits 0 to 9. So I think you get the idea, but taking this one step further, this is sort of an idea for like a method that you can use to sample well-constructed output. And you can specify JSON schemas, source grammars for source code languages, regular expressions. And then with this procedure working behind the scenes, you can be guaranteed your large language model will produce output with the exact structure that you need. So I'll skip over this because I think that'll take away from Cameron's talk. So try it out yourself. So Cameron and Vaibhav, 2 speakers today, their companies produce these really great libraries, firstly outline from .text, both Python libraries with a wide range of integrations, so you'll be able to use them with all your favorite large language models and large language model libraries. So I've got the GitHub there, so check it out, give them a star, try it out, and build some cool things. Okay, so at this point, before we move on to Cameron, our second speaker, just a few notices. So firstly, let's take, actually, we'll do that at the end. Cameron, do you want to come up and, oh yeah, sorry. Does anyone have any questions? Got a few minutes.
This is an example. Of course, as you cascade, as you are cascading, right? From PB out, one down, mass down, the next mass down, the next mass. All right. So for this example, it was really simple. The real world, how many masks are there? Are there thousands? Are there hundreds of thousands?
Yeah, so I think the answer to that is there's a mask, and maybe Cameron can correct me if I'm wrong, but there's a mask for each state, and that's calculated in advance. That's sort of like an indexing step that happens offline, and then that's cached.
Is there any performance hit? It's so simple that not even consideration.
Yeah, in terms of inference hit, virtually no overhead, but I mean, I guess there is the memory overhead of storing this map between states and masks. But I think well worth it given that you get this guarantee. Okay, maybe time for one more question. Just hold on a tick, we'll get you the microphone.
So, the representation of the finite state machine to use in this application of kind of looks like sort of the conditional probability, right? What we do is that these were my previous elections. These are the probabilities of the next one. Is that is the use of finite state machine? Is it just as instead of using sort of like probability, this is the replacement for that? I mean, is that how you see the key innovation in this whole thing? That the user idea of the user finite
sorry, could you elaborate? I think I think it's the microphone. I didn't quite catch the last bit.
okay. So it kind of looks like, so if I the application of the finite state machine here, if I look at what we're essentially doing is like computing the conditional probability of the token given the past token. That's the simplest way of putting it. Now we could implement that a conditional probability computation in a different way that you wouldn't need that finite state machine, but looks like the finite state machine is a more efficient way of using it. Is that the key innovation, key idea behind this?
Yes, yeah, and so I think also that like indexing in advance affects the scalability. So because it's a like you got a hash map from state to mask, then it's constant scaling factor with respect to the number of tokens.
Okay.
So yeah, I think that's I would say that's the main contribution.
And just one more question about Milbus. Sorry, maybe it's not related to this, but I've used Milbus, and this seemed like I've used ChromaDB also, but it seems like, so I was under the impression, for example, when you load the tokens, storage has a very little role to play in Milbus, because you are prefetching everything into the compute memory anyways, right? Just I tried just keeping a very small amount of memory in the compute and just doesn't load, it crashes. So it looks like when you start up the database, you load up everything up front into the compute memory and then everything operates on that. So storage really has no role to play in terms of performance. So is that right way to put it?
So I think if just to paraphrase, I think what I'm hearing here is once you sort of like scale to a certain point, you may not be able to store all of your vectors in memory of a single machine. Is that correct?
No. So it's like, is it any advantage of using a high performance storage? Store those. You are anyways going to load up everything in the compute memory up.
Yeah. So do you mean like using a distributed system versus non-distributed?
Maybe more performance storage in the sense that, for example, flash drives. Let's say the storage is fast enough, but if you're not using that in your critical path, just using from compute.
Yeah, sure. So I believe that there's sort of like a, at least in the commercial offering, like a tiered system where we can store the most frequent data in RAM, and then down the cache, solid state drive, hard disk, more sort of cheaper cold storage. So yeah, there definitely is like this feature. Do you want to chip in, John?
Yeah. So my name is John. I'm also from Zilliz /Mills. Is the question in the setup of this finance state machine, or is unrelated?
No, it's not related to finance state machine.
Okay.
Just that I've been asking to building process question from Zilliz for almost a year.
Yeah.
And I found you.
Well, thanks for the question. That's really a great question. So on the vector search side, usually when we talk about performance and scalability, we're talking about say billion vector scale. And at that scale, there are two ways of solving the scalability problem. One is that you just scale horizontally with more machines. So like for example, in Milbus, we divide the data into segments, shards, so that we have machines taking different segments and they are working or operating in isolation, and they each take kind of a part of the responsibility. That's how it's scaled to billions or even beyond. That's one way. Another way is to carefully design the vector indexing algorithm for the index the structure, so that you store some of the mostly frequently accessed part of the index in memory, and then leave everything else on disk, so that you can leverage the cheaper storage, which is SSD or like even network storage on your traffic workload or the requirements of the business. And so by carefully combining those two storage, and even we also have this concept of swapping data between memory and disk dynamically based on your workload shift. So by using this, you can just store more data and and not really, say, paying like more cost, linear amount of cost to a smaller workload. So we apply both of them on Milvus, and this is called the hosted version of Milvus.
Right.
Yeah. And come and have a chat to us afterwards. We'd love to talk more. Okay, well, thanks, folks. Thanks for really great questions. Can we give a round of applause for our next speaker, Cameron?
So presumably this lav mic is working.
Oh, have you turned your sound off?
Oh, I have. Okay.
Okay, looks like you did.
All right. Oh, I don't want to take a screenshot. Okay. So, wow, he just did like most of my job. That was great. It was like super technical in a way that I'm not normally. So, yeah, I did my PhD and now my brain is mostly slop. So like I needed somebody to do that. Okay, so my name's Cameron Pfiffer. I work for .text, like the file extension. We just covered the fact that nobody actually seems to know what it's called. Okay, all right. So today we're basically going to be building something called the Lore Master 6000. And so Stefan asked me to come up with something that kind of uses Milvus. And I was like, oh, okay, I can do that. And so what I built is an infinite world generator. And so I'm going to use outlines and Milvus. They're two great tastes that go great together. Because we can do structured, we can do unstructured, we can do whatever, and Milvus can handle both. And so the goal here is we're going to make this robot that self-generates lore. It's just going to bootstrap itself to create some interesting new world. And it's going to generate lore that is consistent with everything that already exists in the world. So it won't just like make up characters and stuff if they already exist, and it won't contradict itself. At least that's the hope. I haven't really dug into the results enough because that's hard and it generates a lot of text. Stefan just talked a little bit about outlines, and the thing about outlines and structure generation in general is that you always get perfect structured output every time. You can't actually get cases where like you say, please output JSON or my grandmother will die, and then it just like forgets a colon or like a bracket or something like that, right? You never get this. And so you'll always get this, right? And so that's a promise. If you don't get that, then please open an issue and we'll tell you that you're wrong in a very nice way. Or if we are wrong, then you can tweet at me and I'll say sorry. We do it. We strictly do people-oriented complaint responses. So we're going to use Milvus here to store and search the lore. And Milvus is actually super easy to use. I hadn't really used it before, so it was fun. So let's start walking through. I'm going to show you kind of what the output is, and then I'll walk you through the code. So this will mostly be kind of a demo talk. So where we're going to start is we're going to generate a world. And so a world we're going to generate here by basically just saying, we can give it a prompt. We can say like, if you don't give it a prompt, it'll generate something random. But you can give it a prompt, like here I said, I want to see a world that has like a artificial superintelligence, right? So that's the seed. And so we get something like this, which is like, oh, there's mega corporations that have replaced stuff. And we have Prometheus, who's this superintelligence that's invented by Omnitech, stuff like that, right? So this is the seed of the world. This is the core description. This is everything that we know that's like kind of the meta description of the world. And so what we're going to do is we're going to suggest a lore entry. This is a historical event, a character, something like this. And here the proposal is basically we have mega corporations, Omnitech's Prometheus AI controls much of society, but there's a rebel group, okay? And then we see this information request. So I have the model generate a series of queries to ask our database to see whether or not you can determine what information you need from the database to understand how to refine this and make it clear. And so we need to know more. And so we ask our agent to build queries, right? These are natural language questions. So here it's like, what is the origin story of Prometheus, right? So we say, please give me that. We say, and then we'll get an answer, which is the origin of Prometheus is not yet known. So it looks in the database and it says, okay, we didn't actually have anything yet. And in this case, we don't actually have anything injected into the database. There's nothing here, so it'll just say, oh, okay, we don't know. And so our agent's going to take all these answers. You know, we had 4 requests, and we're just going to combine them. And I added reasoning steps here, and I'll show you how to add reasoning steps because it's like absolutely stupid simple. And so we see, okay, the origin of Prometheus wasn't mentioned. The proposal provides the backstory of how Prometheus. So we want to create some Prometheus origin story that is relevant to our world. Okay? Hello, cart outside. So in the end, we get this. This is in the 21st century. Prometheus was built by Omnitech. It was built by all these brilliant minds and stuff like that, and then it became self-aware, right? So this is the thing that's going to the database. We proposed something that had to do with this rebel group, and it learned that there was no, we didn't know how Prometheus came to be, so we had to understand it, and so this is the thing that explains what it is, right? So we're just going to keep doing this. Once we have more information, this is the thing we just injected, right? The origin story of Prometheus. It'll start asking questions like this. What is the origin story of Prometheus? And then we'll get this result, right? This is stored in the database. So we just did semantic search based on this question. And then we get this vector result, right? We just did semantic search, and we got some information back that's related. You can see the cosine similarity down there. I have my model output keywords, but I didn't actually end up implementing keyword search, so, you know, random crap left over. And then there's more reasoning and queries and stuff like that once this question has been asked. So like, you know, there's a rebel group, we know the history of Omnitech, and so what it does now is it creates the rebel group, because we didn't actually understand anything about the rebel group, all we knew was about Prometheus. And so now we're building new entries. We're learning about the rebel group, we're learning about Prometheus, all this stuff. And so Milvus is going to manage our knowledge base, and then we just do this forever. This is just a while loop. And so over time, you just start injecting hilarious amounts of knowledge into this thing. And then the model kind of starts generating, because there's like weird characters and stuff like that if you use a cheat model like I did. And so how do we do this? So I'm going to show you some of the code here. And before I do that, I'm actually going to set off, that's right, the stupid Zoom bar is blocking my thing. So I'm going to set off this job here, and we'll keep checking in on this, but this is a real live run, loading Milvus right now. Would somebody like to give us the seed? So like, somebody raise your hand. Tell me what you want to see. What you got?
Zombie cannibal robots.
Zombie cannibal robots. Oh yeah. All right. So it's going to start generating stuff. You'll see the seed here pop up in just a second. But while that's happening, test your ASCII, of course, I have to have test your ASCII as my background. So I'm just going to walk through some of the code here, and I'll kind of skip around and show you kind of what's interesting. You actually won't see me import outlines here anywhere. And the reason for that is I'm starting to believe that you need to start like separate a lot of your inference between like your runtime code. Outlines is built for like really resource heavy things. I have no GPU here. I cannot run this live. So we have an internal beta that we're testing for only like serving structured output. So that's what I'm going to use here. And we also check back on our seed, zombie cannibal robots, still going. Okay, so we're just going to load up a bunch of stuff here. I'm using Voyage for embeddings. Oh, here, I can make it much bigger because I know that you have to make it way bigger than you think usually. Oh, you want me to be boring and use light mode? Okay. Here we want, let's do high contrast. Okay, so that should be okay. All right, cool. So I mentioned we're going to use Voyage here, and then I have this generate function. All that does is take a Pydantic class and a prompt, and then it will send it to our API and get it back. Okay? So nothing complicated. So here we're going to start doing some Milvus stuff. This is also very simple, right? I just like copied this from their quick start, and I was like, oh my god, this is super easy. So we're going to make a client here. Oops, I deleted that. I don't want that. Nope. All right, Cameron's already screwing up the live demo. Never do live demo. I was telling my barber about this. Okay, so if we have this collection, we're going to drop it, and then we're going to create a collection called lore. This is just where we're going to store all the vectors. Yeah. I'll show you. Yeah. He was asking about how it knows to go to the next step, and so I'll get to it. Then we're going to use the dimensionality 512. So I'm using the Voyage Lite because it has a longer context window than the default one that was in the docs, and so some of these things can get long, so it's difficult to do the embeddings. So you can use this embedding function. That's the default one. There's all this like kind of leftover code so that I can comment a bunch of stuff out if things stop working. Which let's see if they did. Yeah, so just to revisit this part here, the world description. On a desolate Earth, devastated by a robot uprising gone wrong, hordes of zombie cannibal robots from the landscapes, blah, 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 blah. So this is a post-apocalyptic setting here as well. So good rec. Let's see how that evolves. Okay, so then we're going to go into our general story structure. We're going to define this by basically just setting up a bunch of Pydantic classes. Like nothing complicated. You're going to program like in the Python that you already know. Okay. So I'm going to have this thing called a lore entry. This is a name. Oh God, that is not where I thought this was. Okay, cool. Wow, a lot of latency. Okay, so a lore entry here is going to be composed of a name. It's going to title this lore entry. It's going to have some content. It's going to have keywords. Notice here, I'm just typing this. It's going to say a list of strings. So my model will always give me a list of strings that are separate keywords. And it knows it has to print out keywords because on the underlying JSON, when it's printing it out, it'll hit keywords, end quote, colon, bracket, and it knows it has to start spitting out keywords, right? So the language model is actually very good at doing this. I'll just get past this stuff. This is just for making embeddings. And then this part is where we actually talk to Milvus. We're just going to do insert self-client embedding function. And I'm just going to convert whatever the lore entry is, the actual object of the lore entry. I'm going to convert it into a JSON. And then I'm just going to add the vector to it, the embedded vector. And then I'm just going to inject it directly into the database, right? Nothing complicated. That's all. That's like most of how you use Milvus here, or at least how I do it. Okay. So then we have this thing called setting type. Setting type here is just an enum, right? So it's basically saying the model must. Oh man. How do I get this to? Okay, there it is. Okay, so we basically force the model to choose from one of these setting types. In this case, you gave us this example of like zombie killer cannibal robots. So it looked at that and it was like, this is post-apocalyptic. That's the closest thing to it. If you don't provide something, it will pick something from here and the entire word description will follow from that. But having this seed made it choose something that was more likely. Oh man. Okay, well. Okay, well, that's very annoying. Is that doing that? Okay, hold on. I'm sorry, that's very annoying. I know it's loud. All right, cool. I wonder if I can turn this off and turn it back on. Reshare. That's the move. All right, let's try it. That'd do it. Okay, cool. So let me go to world. Okay, so this is the prompt for the world builder. I'll get to that in a second. Everything's moving fast, so whatever, or slow. So a world here is just the combination of a setting type, post-apocalyptic in this case, and then a description of the world, right? That was the thing we saw in the green text at the very beginning. Okay. And then I have this proposal prompt, right? You still have to write prompts, right? You don't get like structure generation doesn't give you like crap for free, right? You still have to describe what it's supposed to generate. The advantage of doing structured text is it will always give you the thing that you wanted. The structured text can help guide you, right? In this case, it knew that it had to be like post-apocalyptic and it kind of fell into the slot. But you still actually have to write stuff. So all this is basically just saying, you know, you have to pick one of these things and please generate us a world and just kind of be general. Then there's this part here, which is generating an event proposal. I'll talk about that in a second. But basically, this is look at the world, tell me something you might be interested in knowing. And then we'll refine it over time using what's in the database. Okay. All right. Doot, doot, doot. And then we have this generate world function. All that does, generate a world. That's it. That's the entire thing. That's all you need to do to talk to the language model. You move on with your life. You have this world class. It defines everything you need to, and it's just a Pydantic object. You can program it with it like you normally would. And then we see this part here on the bottom, lore entry candidate. So this is when you generate a proposal. This is the result that says like, hey, Prometheus is like maybe this, right? This is its guess about what it wants to enter into the world. And so you'll see here, there's a proposal that's just unstructured text. It says like, this is what I would like to put into the world. Then we have reasoning steps. And notice like, when you're adding reasoning steps, all I did was write reasoning steps list string, and then it has to do reasoning. I wrote a little bot called an anxiety bot that does reasoning and then reflection steps recursively over and over and over. And you can make it be really anxious and indecisive because it thinks way too hard, right? And so all it is, you can make force structure in your model by just adding simple fields. And because it has to print them in sequence, you get free reasoning. And so it was really, really easy to add this because I was like, the results are really terrible. Let's add reasoning. And then it just started working. It was generating stuff that wasn't internally consistent with the world. And then we have this information request answer. And so this will take a look at all of the search results, perform some reasoning steps, give you an answer. So you'll get the information request, like, do we know anything about Prometheus? It'll look at the results, it'll reason and say like, okay, we didn't actually see anything in here, then come to a conclusion. That's all you need. Then there's a prompt here, but we can skip over that because prompts are long. Point is, you still have to do some stuff. Okay. And then we're just going to kind of start with the world here. So this is where you say, okay, give us our seed, right? This is the cannibal robots thing right here when you ask for a world type. All this stuff here is old in case things went terrible. And then we generate our world, right? So at this point, we have our description, we have the setting type. In this case, it's like this kind of cannibal world, right? This is the thing that we saw here on a desolate earth devastated by uprising gone wrong. Make it bigger. Okay, it's a bleak melting pot of urban, industrial, and neo-Gothic architecture, right? So that's the thing that we get from world generation. That's what we printed out here. And then we're just going to enter this infinite loop. And we're going to propose a historical event. And notice here, we're passing the lore entry candidate, the class. We're going to get an object back of type lore entry candidate. And then I can print this out. So here's a proposal. All it said was the forgotten sanctuary. And it asked no questions. It was like, let's just pick some word, the forgotten sanctuary. Like, what could that mean? Okay. And if there's no information requests like there is here, it'll just inject it directly in. It'll try and refine the proposal by looking at the world and providing more information, something new to add to the world. And so here we have this like forgotten sanctuary. It's a grandiose manor built by blah, 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 blah. It's gotten really talkative and I'm trying to cut it down, but this is what happens when you work with language models. They yap. Okay. And so it'll do the new proposal, the fall of Robotica Corp, same thing, no information requests. Let's take a look at here when we actually do have an information request. So we have the Fortress of Iron Will, and it's asked one question about the Fortress of Iron Will. And it says, does Fortress of Iron Will have a leader or governing body? And then we have some existing results. These were all retrieved from our vector database. Based on semantic similarity to this question, does the Fortress of Iron Will have a leader or governing body, right? And then we have a bunch of results here. Oh man, okay, so this is what happens when you use a small context model. Oh man, okay, never do a live demo. But so I'll return to the code here in just a second. I don't know, cats. So many cats. Okay, so we'll see what that does. But basically all we do here is inside of the code, we ask a question from our information requests. We go and retrieve this using Milvus. So this is client.search, collection name, lore. We embed our search queries. And then we have some output fields that we can pull back from the underlying document. The nice part about working with Milvus is it's like basically a document store. So you can inject like whatever stuff you want in there. So that's like, I pulled this stuff out. I limit it to 3 again because of context like restrictions here. I'm using the llama models and they're like really dinky. They should make them bigger. I'm really upset about that. And then we're just going to go through each of the results in that information query. That's all this stuff prints out. Let's see. How much longer do I have? Then we get our answer. So then we're basically going to take our proposal, and then our request is like, what is the question? And here's the search results about that question. And so what this part does is it passes to the model a prompt that says, this is the world, this is what somebody proposed, this is the question they asked about it, and here's relevant information. Please tell me, is the question asked, can it be answered by what's inside of the vector database? Okay. Then we're just going to pass it to our model. We're going to get an information request answer object out. And then we're just going to append it to answer.answer. And then we can print some reasoning steps just because I think it's interesting to see the reasoning steps. I always think they're super interesting. And then once we've answered all those questions, we're outside of this query loop here. And then we're just going to say like, oh, okay, convert our world to text. This is like description setting, right? It's super basic. Then we're just going to start adding like the proposed lore entries, the information request, and the answer, just like dump all this stuff in the context. This part here is what normally where the language model, like where we hit the context limits. Then we're going to add some system tags just because like, you know, we want this. It gets weird if you don't add system tags in this example, and I don't have it auto-supported. And then we're just going to refine it when we get a new lore entry at this point. So let's see if we actually had the cat whisperer going on here. Okay. Oh man, all right, we're going into some stuff. I don't even know. Okay, so there's something called the cloud walking path here. Is there a celestial mountain in Haravath? And then we have like, this is some results about terrain is diverse, comprising of rolling hills. So that may tell us whether or not there's a celestial mountain, but it's nothing precise. And so what's the mountain significance in the local folklore? Again, we have some more responses to this. And then we have reasoning steps to answer this question. So the Seattle lore, I don't know what that is, mentions the dusk cat, a legendary and mystical feline. The dusk cat roams the land. The mountain, the cloud walking path, is likely significant to the local folklore as it is part of the terrain and could be influenced by the legends of the dusk cat. Right? So this is it thinking through the stuff that exists in this world, and I've completely lost track of what's going on here because this is a new world. And then we get an answer. It is likely that the cloud walking path mountain is significant to the local folklore due to its association with the mystical dust cat, right? So this is cool. This is answered like something about our world that we didn't know before, or we do know, and then we have to communicate it to the entity that is kind of expanding this world. So this is actually like a multi-agent system, right? Where you have like a core agent that is like trying to understand the world, it's refining something, it asks like sub-agents to go do research, they come back, they give you information, you can refine the proposal and move on. Okay. And then we inject something like this, and it explains, it expands the cloud walking path, which is a formidable mountain. So create something new based on grounded information from the database. So I'll kind of like just kind of wrap up here. Basically, you just get the same kind of stuff, just like new proposals. You look at what exists and you keep going, right? So this was actually a really fun application. I really enjoyed tinkering with this, and I hope that it starts to like get you thinking a little bit about the fact that I just programmed in this. This was not like I didn't have to sit down with like a crazy amount of prompting. I didn't have to do any of this stuff. I just wrote code. And I got this like really simple agent system in code. You don't need this like gnarly ass DSL like Swarm or whatever. You can just write raw Python and you get free agent system. And so I really enjoyed that for this, just like kind of learning about how all this stuff works. So I'll call it there. You can ask some questions if you want. Here's our Twitter. This is our website. That's our GitHub. Go give us a star if you want, because we're star hungry. And my name is Cameron Pfiffer, so I hope you enjoy. Anybody have any interesting questions? I think I've got like 2 or 3 minutes for questions, presumably. Yeah, okay.
So there's a lot going on on the board properly. But we're talking about that vector model for storing these facts that are generated. We have something generated creating that. But we don't necessarily have a knowledge graph or so on. And what's interesting is how is this emergent property happening of proposed entry being at all consistent with the previous? One's at Neo Atlantis, so that's actually versus Kristen, and the next country says he's open, or one has different. There's still lots of like, is it because that inherent properties emerge from the fact that because you'll retrieve three relevant facts for pieces of existing lore, synthesize new pieces of lore locally grounded in those three? Or am I on the correct path entirely and there's nothing here? He says, once this thing is generated 35 different entries of lore, those 35 entries of lore are
Yeah, so you're right that this is not perfectly consistent. So your question was basically, is there like an exact knowledge graph? And the answer is no. You could expand this with a knowledge graph if you wanted to. You know, if I had significantly more, like there is a version of this where you extract every single component of this into a single fact, one sentence. And we're limited here by kind of, you know, I let this unstructured. You don't have to be this structured. You can basically say like, I could have like expanded lore entry as main character, location, what happened, etc. Those things would help you be more grounded, but you're right that you may need something that's like more neurosymbolic in nature to kind of give you something that is formally grounded, right? So that's something like a knowledge graph and things like that. So we are also limited by context window here, right? Because I can't do more than 3 entries because they're pretty long, and so like the model craps out if you go more than 8,100 tokens in the case of long models.
But in that case, it could be similar to this demo, instead of lore being sprinkle effect and trivia, right? So shredding Lord of the Rings into 1,000,000 one-sentence packs would be extreme. Again, probably going off that access of work to the demo, but the fact that the structured dialogue process works is a matter of reason. Hopefully, it doesn't hallucinate on generating the fourth thing based on these 3 examples. We have likely that this whole thing stays centered on.
Yeah, so groundedness is still a problem, right? I think you can, like, this is super prototype, right? You can do this as like a 1-sentence thing, 1-sentence facts. You can start having like, you could start doing like a MapReduce style search where you say like, here's 5 search results, here's 5 search results, you guys go deal with this. You can have aggregation agents that look at all the results and say like, well, we passed those guys this thing, we passed those guys this thing. Do their answers seem consistent? And you can walk it all the way up the chain. Right, so you can get arbitrarily more complicated as you have like more complicated documents. So there's a lot you can do, and the advantage of working with a structured text thing like this, just code, right? You just like add another class. You can change the style of the classes where it's like, yeah, okay, I want to have like name, entity, location. An early version of this, I had heroes that had name and class and stuff like that, and had to go retrieve heroes, but it was too complicated for a demo. But you can really start expanding. Like how everything flows by just adding additional structure and writing code. All right, cool. Thank you so much, everybody.
Thanks, Stefan. Someone can turn that into like a, I don't know, like a text adventure game that each time you play it's different. That would be really cool. Okay, so let's move on to second speaker. So let's welcome Vaibhav to the stage.
Awesome. Cool. Thanks, guys. Thanks, Stefan, and great talk, Cameron. I'm gonna try and do demos, so I'm gonna try and talk ideally without the microphone. Can you guys hear me? No, not really. Oh, that's gonna suck. What did you say? All right, I'll talk really loud. How does this work?
Yeah.
Oh, okay, that'll be great. I'm gonna need both hands to type in code. I'm gonna need both hands to type in code, but what I'm gonna end up talking about is called BAML, and we're gonna talk about a new way of doing structured generation. But before I go ahead and do that, let's go ahead and just see some demos of what you can do. I think these guys mentioned cool things, but let's look at some, I don't know, let's, I have this weird one here that I think most people have probably never seen before, which is the visa form for Cambodia. So here's what we're gonna do. We're gonna take this image of that visa form, and then we're gonna go ahead and process it. And right now what the model is doing, it's actually generating BAML code. And once we get the BAML code generated, we're gonna go ahead and execute that. And it's hands off, so we'll see if it actually works, because LLMs. Oh, shoot. Sorry, I ran it twice. Well, that was my bad coding on localhost. but we'll see it working right over here. And what we're actually going to do is we're going to have a vision model. We'll have a vision model actually go ahead and read the PDF, define the structure that comes out of this model automatically. And because it's not Pydantic and it's not TypeScript or any specific language, but it's actually a model, it's actually a syntax that is very easy for models to execute. What we're actually able to do is the model will go ahead and define this code right over here, as you can see it. And it will go ahead and define this. And like you said, it's just code. So I can actually edit it. And then I can actually go ahead and execute this code. And when I go execute this code, you'll see it's going to pull out all that information automatically. And all this data is guaranteed to be exactly the schema that I define in the code every single time. And we'll see if it does some interesting things. For example, see this checkbox over here? It turned it into is true, which is a lot more useful than the checkbox. These data points right here turn into checkboxes. I'll zoom in a little bit so we can like see some real facts. How do I zoom in? So you can see exactly what it's doing on the image and the content. We can do it with a slightly more fun image, which I find is the photograph. What do you mean by that? We took that content, we passed it to a model. The model went ahead and generated what I call BAML code, and I'll show you what BAML code looks like in light mode in a second. And then we went ahead and executed that code to get this data out of it. What's interesting is we can do it with all sorts of things. So I'll do a little webcam image so you know it's not rigged. And it's going to go ahead and try and describe something here. And it'll generate the schema. Hard to see the schema made for, sadly, developers who hate light mode. And then it will go ahead and actually, oops, did I rerun it? Oh, I pressed enter again. The only problem with LLM demos is if you do them real time, it's actually kind of slow, which kind of sucks. But if I zoom in, you'll see what it did. It kind of invented this structure off of that thing, off of my picture automatically. Then we went ahead and executed that structure and got it out. Now we can do more interesting things. It works in audio, image, video, text, anything you want. And the best part is this is all just code. I want to show you another example really fast of something you can do with this. Oh, I got it. So let's do another one. This is a little hackathon project we built. So like I said, we have our own programming language. Teaching people questions about a programming language is an essential part of our Discord. Right now, I used to be able to do it. Now it's kind of hard for me to do it because we wake up to bugs or questions most days. So let's say we ask the interesting question, like, how the hell do you define enums in BAML? I'm going to go ahead and type that in. And what's going to happen is it's first going to detect the fact that this itself is a question. And it's going to start kicking off a process. So the first thing it does is it looks in our documentation. It goes ahead and finds some information. It determines that it's ready to answer the question. And then eventually, it's going to actually go ahead and produce an answer. But we're really anal about our quality on our Discord. We don't actually want it to mess up. And most LLM pipelines won't. So once it comes up with exactly what an enum is, and this is actually pretty good. It described the code. It showed you exactly how to do attributes. It defined a function using enum and even gave a snippet. But maybe the person asking was looking for a TypeScript snippet. So what's actually going on here is it's actually going to ping me in Slack in a second. Problem, I think the internet's kind of slow. There we go. So it's going to ping me in Slack. And I can actually say request changes. Oh, not this one. It's waiting for the next message. Where's the message? Okay, I'm going to run in terminal actually, because that will be faster. Say that again? Say that again? We just use a vision model. We had no idea what PDF we threw at it. You could throw any model at it. You could throw any PDF, CSV, website, anything you throw at it. It will automatically figure out a structure for it and give you that structure in the same format. So like, let's see if we can get this work. Well, I don't know why it's not pinging me, but let's see if you guys want to see my environment variables, then we can make this work really fast. vi.end. Here, don't steal my keys, please. Also, I don't really know Vim. Don't judge me. I have to scroll to the right and delete this whole thing, and then it'll work. I'm good for now. Thank you, though. WQ, I've successfully left Vim. And then I'll go back and show this again. I'll rerun this again. Sorry about that. How do I use enums in BAML? So what this will end up doing is it'll do the same thing that we did before. It'll probably be a little bit faster because it won't actually hit the remote service. But the first thing you'll notice that it's doing is it's going to go ahead and start answering some questions to determine the answer. And then before actually answering the question, it's going to go ahead and ask me what I think about the answer. And normally it should ping me in Slack, but right now I'm just going to ping myself in terminal as soon as this thing runs. And then I'll actually say, no, add a TS example. Well, let's use Ruby because you can use BAML with Ruby as well. Add a Ruby example instead for the end usage. And then what it's going to do, it's actually going to go ahead and take my feedback and then rerun the queries again. And it's going to go ahead and say, okay, I have enough answers to answer for Ruby. It didn't end up needing to look up bot again. And eventually when I say it's good to go, LLMs are so goddamn slow. It's going to go ahead and say, here's the answer. And one thing you'll notice here is it actually did the whole thing as before. But this time, it actually literally gave the exact Ruby code that someone needs to use to be able to use BAML in the Ruby client. And all I say is, good to go, and then I'll just ping them on Discord with that exact text message. So what the heck is BAML? And like, should you actually consider using it? Probably not, but maybe. But I'll talk about why you might want to consider using it. The whole point about, could you help now? Now I'm going to need to type a lot. So the whole point about BAML is the fact that if you are going to go ahead and write complicated systems, you really want to have a system that is robust and reliable. You guys remember the day when we did the websites like this? And you did something like this, and eventually you'd hire an intern and somehow they'd forget the closing div tag and now your entire website is hosed because the div doesn't close correctly. It's because strings are useless. You cannot do anything with strings. You can't validate their correctness. You can't statically analyze them. So eventually we all decided that the right way to do this was to use this new language called TSX. And the way TSX works is you can do this. And when you forget the closing div tag, it will yell at you and say invalid code, which means you can catch errors at compile time, not runtime. Compile time almost always helps you build complicated systems. And that's why today, a freshman in college can make a website really fast. The problem with LLMs is that LLMs are basically the ultimate stringification of everything. If LLMs get really freaking good, we won't write code anymore. We'll just write prompts, and somehow they will work. That's scary. But if that happens, we're going to need to do something with our strings, like we did with our websites. BAML exists as a programming language to fix that problem. So let's take this example. What I want is I want to write a function that takes in a resume, takes in a string or an image, and it will output a resume data model. Now I actually define everything in code. I don't write any prompts. I don't go do anything. I write everything in code. And then I write some stupid prompt like extract this content. I plug in some macros that we have that describe the data model. And then I can write system user messages about plug this into here. Now what's really important in LLMs is you better be looking exactly at what your prompt is. We built that right into VS Code. You can actually go ahead and see the exact prompt right here. So while you're actually editing, you will be able to see everything. Not only be able to see that, you'll be able to see your tokens. This is probably not important if you're starting out, but if you're really beginning, once you get really into it, it does matter. For example, maybe I should put a dash, dash, dash to surround my resume with something else. Here's how I would do that. Now, is that good or bad? Let's take a look and see when it becomes bad. All of a sudden, I actually used 2 tokens by accident. By adding 1 extra dash, I suddenly used 2 tokens now instead of 1. My thing just became a lot more complicated. If you're not looking at this, it's like writing CSS without looking at the website. It's the same problem there. So not only are we able to do this, but we can actually do structured data in a way that requires no modifications of the model. Let's take a look and see what that means. So firstly, you can actually see the raw web request BAML makes. We don't change the prompt at all. The prompt is exactly what I said over here. Extract this content, boom. This is ctx.output format. I'll take this out and you'll see it's right there. It's literally just that variable being plugged in. And down here is just the resume. Now, what am I rendering down here? Why am I rendering? I want a McFlurry with fries. It's because I have a test case that I also define in BAML at the bottom. My test cases also exist in my code, not in the UI that has to go run. So when I actually click around, let's say I click on this test case, my test case changes. But the one last thing that you can actually do is you can actually run your tests right here as well. So let's go ahead and run this, and I'll show you an image version as well. So like, let's actually work on rendering images as well, right in scope. But let's just run a quick little example of what's going on. And cool, we got something kind of nice. The LLM output something. This is all JSON compliant, and it works. This thing took 104 tokens. Let's see if we can do better. I'm going to add a string in here. Don't use quotes around keys. So the idea is the only reason we're really using quotes is because we need this to be JSON compliant. What if we didn't need it to be JSON compliant? What if it just needed to be kind of compliant? So check that out. See how it's parsing it right there as it's running without even doing anything? That's because BAML does that for you. We have a compiler that does automatic error correction on the outputs of models and is able to go ahead and take something that is approximately correct and still make it compliant with your data model. So what does that mean? This means that your cost that used to be 104 tokens is now 80 tokens. It's just 20% cheaper. No hit. In fact, not only is it cheaper, it's actually going to end up being more accurate. I think Cameron made a great point about doing reasoning. Let's see if we wanted to do reasoning. Let's try and do that. List. Let's see what it looks like in BAML. Before answering, list out 3 most impressive things the person has done. And we'll actually like we'll give the LLM a small example of what that might be. And I'm not even like, this is like some stupid prompt, but LLMs, it turns out, are quite good at understanding what I have many things, but I cannot type to save my life. My typing speed is like 30. And you can see the exact prompt that I added. There's literally no shenanigans. It's right here. So let's go ahead and add this in and try and go run this same prompt again and see what happens. So the LLM is going to start outputting things. And even though it outputted this, has no quotes, we still parse the data correctly. You literally you didn't have to think about it. Oh, you can't even see the output. Whoops. I'll put the output here. This is the output that we got out of it by copying the JSON. It's completely compliant and will never require any work on your end to go ahead and go do this, even though the actual output that we got from the model looks like this. Sorry, zoom window. So even though the model looks like this, we're able to turn that on the right in under 1 or 2 milliseconds, turn that into the thing on the left. And you have to do no extra work to go do this. What that means is you can get by with way worse prompts, way shorter prompts, and make that even super easy for you to use. So that's just BAML. How are you going to put it into your application? How are you going to add it to your Python code or your TypeScript code or Ruby code? BAML works with every programming language out there. We have people deploying us in over 12 languages, all the way down to ASP.NET, which I didn't think people really use anymore, but they do. So let's talk about what that looks like in here. I'll hold it. I feel like your arms are getting a workout. And I will hold it under my arm, and maybe it'll be a little loud. So we have this function over here called extract resume. Let's see what that looks like to write a Python file that uses this. foo.py. All you do is you do from BAML client, import B. Are you guys able to see this, by the way, just fine? Perfect. And you'll notice that everything here is going to autocomplete. So we'll do resume equals b dot extract. I have a bunch of functions. Extract resume. It'll just output, I'll put in a string into it or an image if I wanted. And resume.experience is going to be a list of experiences. Why is it a list of experiences? Because resume is defined to have experiences be a list of experiences. If I change this to a string, what do you think happens here? This thing will change the list of strings. It is perfectly in sync. You never have to worry about your BAML types not being in sync with your Python, TypeScript, Ruby, any language you want. So if you have a larger company with people using you across multiple languages, you can write all your LLM pipelines right here and then see everything be completely continuous. Now, if you're streaming, it's a little bit weirder as well. b.stream.extract resume. And we'll read this resume and we'll do for partial in resume and stream and partial.email. Email will actually be, and it's completely compliant over here, email will actually be an optional field. Why? Because you're streaming. You may not have it yet. It's not going to be ready. But when you actually go get the final response, stream.get final response, response.email, it's guaranteed to be perfectly compliant. So you get complete static analysis and complete guarantees while you're going to go do this. You have a question? So there's different ways to use BAML. You can actually define schemas at runtime as well. So we have a lot of people defining schemas at runtime based on like things that they load from a database. But you can also statically define schemas like this. So you can do it either way. In the PDF example I did at the very beginning, I knew nothing about the PDF. I actually generated the schema on the fly. So while I'm doing this, you can do the same thing in TypeScript, Python, Ruby, like I said, with any other system, and you get the same static analysis guarantees. Now, the problem with a lot of these complicated systems is most of the time, you'll find that, hey, this thing, which is a list of experiences, what I actually want to do with the LLM is the LLM is going to mess this up unless I call this experiences with an S, because it's an array, so it should be plural, and it will mess up if I don't let it be plural. But if I did that, I would have to refactor all of my code and my database schemas to go rework that. That's going to be a pain in the ass, just because the LLM changed. We allow you to do that dynamically in the language itself. So you can actually just say, and now for the LLM, if you go look at the prompt, it is going to be, it is actually always going to list the word experiences. Oops. The LLM is going to list the word experiences, but when I go run the result, it will still give me the experience data model in Python, and it'll always be completely compliant. So it allows me to have flexibility by changing what I put into the model and not making that compliant with what I put in my code, which for larger systems, again, makes a huge difference. What's really nice about this is you don't have to make any modifications to the model. The thing that I was showing you at the very beginning where I was able to, let me go ahead and run something. Where I'm able to go ahead and like take this data from here and then convert it to like some compliant schema over here without writing any extra code is something you just take advantage of that happens in under 1 or 2 milliseconds. And we use 0 models to go do this. So we don't modify the model. We don't actually use a model. It's a completely deterministic algorithm that has been getting better over time. I'll pause for a few seconds. Yeah. Exactly. So for example, like what happens, so one of the problems with using, so OpenAI, for example, does something called constraint generation, what I think these guys were talking about earlier to produce JSONs. So the problem with constraint generation is what happens when the user like screws you, because you said you want to get out a resume, but then the user says something like, I want a McFlurry and fries. What happens? The problem with the constraint generation is you will get a resume even though you don't want a resume. And in this case, what we do, unlike constraint generation, is we'll actually raise you an exception, which is equivalent to you calling an API on GitHub and GitHub not giving you a repo, but giving you something totally random. You don't want that thing that's random. You want the exact thing that you said. And forcing the model to actually output the exact same thing can actually give you mistakes, not corrective behavior. So that's how, like, I think the title of this talk, I think I put this on here, was something about better structured data than OpenAI. The reason that we're able to do that is because we don't end up having to do some of the things It's a lot faster. It's a lot cheaper because we showed how many less tokens it is, 20 to 30% less tokens. And when we actually go run the benchmarks, we get something really interesting. This thing over here is, let's zoom in, maybe. This thing over here is OpenAI doing structured generation. What we found was really interesting is GPT-3.5 with BAML. So no modifications to that model, one of the oldest models on the market, ends up on the standard function calling benchmark, hitting 90% accuracy, 90.5%. GPT-4o hits 88.95 with structured data generation. We can beat GPT-4o with structured data with GPT-3.5. In fact, we can do this with most models, like all the way down to 3D models, and end up outperforming, because from what we have seen, the models are really, really good at roughly answering the question. What they struggle with is giving you exact schemas and exact formats that are exactly what you want. And that's the problem that we solve with algorithms rather than by modifying the model.
Example that you saw where
Yeah.
we have a bunch of text that has a stack of
Yep.
with analysis done on
Yep.
the stack. We have structured language that provides information, and there's a bunch of like traces from a log file that's a stack.
Yes.
That automatically separate them up.
Yeah, almost definitely. So we have people, for example, doing so the question was, if you have an image of stack traces, could you automatically infer the schema and then pull out information out of that in a more reasonable way rather than just a stack trace? We have people doing very similar things with like audio transcripts from like hospital systems and doctor-patient transcripts, where they literally take a 40-minute conversation. And doctors are really picky. I don't know if you guys know any, but they have their very specific way of writing notes. They're like programmers in tabs and spaces. Like they want to write notes in the exact same way that they want every single time. So if you're going to build an AI pipeline that takes their audio transcript and puts into a database, and you can't put into their schema, you can't sell the product. So what these guys did was they took their historical notes from these doctors, for each doctor individually, generated a schema dynamically, and for every new transcript comes in, they guarantee it comes out in that structure. So I think that's the same kind of problem with your kind of situation with stack traces. So if you're interested, I can tell you how to go do that and what the code looks like.
That's not style transfer, because you have 40 doctors and 40 artistic
Yes.
styles, and when you use the wide marker or a brush, and you say,
Yes.
you take the same text and render it in the style of Edgar Allan Poe or the style of Dorothy Ross. You're talking about actually with a per doctor schema.
Yes. And that works fully dynamically, because you just take their old notes as historical context for how they want to format the notes, what sort of content they want, use that to build your schema model, and you do it across 10 images or 10 historical notes that they have in the database. You just define what is this general structure of all of these schemas. You have the doctor approve that, and once they've approved it, you generate that schema every single time with 100% confidence. Yeah. Most hospitals, I mean, with handwriting stuff, I wish I could. Any of you have a name tag that's handwritten? We're gonna see what it does. Like this is like even our shitty version of this. Can I get your name tag, Stefan? Do you want to pull up? Oh yeah, let's try that one. This is like a handwritten name tag.
Yeah, but how you interact.
So let's just see what it did. Right there, it works.
There you go.
Yeah. So the thing, so I agree that it's not a great example, but I think the point of the point that I'm trying to make is these AI models are not magic. What these AI, I think the best, and I'll pull up something that I think helps articulate what I'm trying to say. I don't know if you guys have seen this. Have you guys seen this? Oh, sorry. I hit the punchline. These AI models are really, really good, but if you don't know how to orchestrate them and how to combine them in most interesting ways, you really can't hit the level of accuracy. For example, like the thing that I showed you at the very beginning that does this has a multi-step AI pipeline. It's not a single step. In fact, I even have a human in the loop part of this as well. I use a vector database, I do search, and then I also have, in the end, like a human involved to go build this pipeline. We've done the same thing with, like, for example, parsing bank statements. So if I were to go ahead and just parse it, I have a bank statement somewhere here. If I were to go ahead, say that again?
Give us your API keys. Sure.
Exactly, why not? If I were to go ahead and try and parse that bank statement with a single AI model, I will get errors. But if you build a pipeline, so we have people, for example, parsing 100-page bank statements that they used to pay over $1 to $2 million a year for to just get that data out of it. Now they parse PDFs. They have 0 sense of error after parsing 100 pages. So it kind of, the model itself is kind of wrong. What we have is we have a special syntax that we released in BAML that allows you to go do interesting things. So for example, what if I want, if I was, I think I have an example of like transactions in here, and I'll show you how you end up writing that code. 3 minutes, cool. Come here. So I'm gonna go to my get transaction functions. This transaction over here, if I want to guarantee that the amount is always going to be less than the balance, then I can just do an assert amount less than balance. And this new syntax will basically just let you build that confidence automatically, and we can do error correction to go correct the model for you. So you can actually go ahead and detect when things are wrong, and when things are wrong, you can go ahead and make another inference call to go ahead and correct it. And that loop is quite good at getting you really high quality results. But the whole point is, instead of writing 50,000 lines of code to go be able to build something like this, we let you do it in really expressive syntax. And expressive syntax has that same benefit I showed you at the very beginning about HTML, which HTML is really hard to maintain in Python, really easy in TypeScript, because we're able to do a lot of checking on your behalf for you. I think I'm running out of time, so if you guys are interested.
Where do you draw the line between adding spreadsheet like math to this thing, saying account out of the balance where the account amount is more than 10%?
We let
say total number of years of experience in the resume.
You can do anything you want. It's a programming language, so it lets you do whatever the heck you want. Yeah, exactly. So that's. Oh yeah, BAML stands for the PC version or the non-PC version. No, okay. Now, officially on our GitHub, it says basically a made-up language. But the non-PC version, the original name that we came up with was Basic Ass Machine Learning. So that's what it stands for. So that's our GitHub. Check it out. It's fully open source, built in Rust, so it's super fast. And it should just plug into your repos, hopefully easily. I think that's it.